Hello everyone, I'm Hyunjong. Before I start the presentation, let me explain what deposition, PVD, CVD are and why I choose this topic. Deposition is heating and evaporation of metals or compounds in a vacuum to coat the surface with a thin film. PVD means physical vapor deposition, and it is a thin film deposition process that involves the physical evaporation of a solid material and its subsequent deposition onto the substrate. This is typically achieved through techniques such as evaporation or sputtering, where the material is transformed into a vapor phase and then condensed onto the substrate. CVD means chemical vapor deposition, and it is a thin film deposition process that relies on chemical reactions to produce a desired film on the substrate. It involves the introduction of precursor gases into a reaction chamber where they undergo chemical reactions to form a solid film on the substrate surface. Why I choose this topic is the miniaturization of semiconductors. Deposition is the key of miniaturization of semiconductors, and there are two processes in deposition process, so I choose this topic. Now I'm going to compare CVD and PVD in deposition of the front process in the semiconductor manufacturing process. The first difference between CVD and PVD is principle of operation. PVD operates based on a physical mechanism. In this process, the deposition gas is converted into a gaseous state and then directly deposited onto the substrate. This conversion is achieved through physical actions such as ion collision and sputtering. PVD can be implemented through various methods such as electron beam deposition and sputter deposition. On the other hand, CVD operates based on chemical reactions. In this process, precursor gases undergo chemical reactions to form solid deposits from the gaseous state. CVD involves the formation of atoms or molecules through chemical reactions in the gas phase, followed by their rearrangement on the substrate surface to form the thin film. CVD is highly influenced by factors such as chemical reaction rates, particle flow, and atomic interactions. The second difference between CVD and PVD is thin film characteristics. Thin films formed by PVD exhibit high density and dense crystalline structures due to physical deposition process. These characteristics result in relatively uniform and compact thin film. PVD can be used to form thin film of various materials such as graphite metals or oxide. Thin film formed by CVD, on the other hand, are solid deposits formed through chemical reactions. CVD thin film can exhibit diverse characteristics depending on the reaction conditions. For example, they can have polycrystalline structures, single crystal structure, or amorphous structures. Additionally, CVD allows for the formation of chemically stable compound thin films. The third difference between CVD and PVD is temperature. PVD can be operated at relatively low temperature. Typically, PVD processes occur in the range of a few hundred to few thousand degrees Celsius. This is because PVD primarily involves deposition through physical action, focusing on the motion and collisions of solid particles rather than requiring high temperatures. On the other hand, CVD requires higher temperatures to operate. Generally, temperatures ranging from a few hundred to several thousand degrees Celsius or higher are required, and heat is needed to enhance reaction rates and the activity of atoms molecules in CVD process. The chemical reaction rate and atomic interactions are significantly influenced by temperature. The last difference between CVD and PVD is complexity of equipment. Typically has a relatively simple and user-friendly design. It is often implemented with a straightforward configuration or for generation in deposition gases and supplying targets. It involves various factors such as supplying reactive gases, maintaining controlled environments, and monitoring chemical reactions. Due to the frequent need for the temperatures and precise control, CVD system requires intricate thermal management and gas control system. These are all information about difference of CVD and PVD in the semiconductor process. I hope those information will be helpful to increase your knowledge about deposition process. Thank you for listening my speech.